Hey, my name is Felipe and welcome to my channel. In this video we are going to make an image classifier. Image classification involves classifying an image into different categories and is one of the most important fields in computer vision. I'm going to show you how to make an image classifier which is very simple, very robust, and it works 100% in Python. I'm going to walk you step by step through the entire process, how to prepare the data, how to train the classifier, and how to test its performance. So, following the steps of this tutorial, you will be able to build a very robust image classifier in only a few minutes. So let's get started. So this is the process in which we are going to be working today in today's tutorial. You can see that this is a 4 steps process, so training this image classifier will take only 4 steps. This will be a very easy and a very straightforward process. Now, let me show you the requirements we are going to use in this project. We are going to use scikit-learn, scikit-image, and numpy. And the image classifier we're going to use comes from the library scikit-learn. This is a library which is very popular to solve machine learning related problems, and if you want to work with computer vision or with machine learning, you will definitely need to be familiar with scikit-learn. So this will be a very good example, this will be a very good opportunity in order to get more familiar with scikit-learn. Now, let's start with this project, let's start with this tutorial, and the first step is preparing the data we are going to use in order to train this image classifier. And now let me show you the data we are going to use in today's tutorial. This is the data we are going to use. You can see we have 2 different categories. The categories are empty or not empty. This sounds very strange, but let me show you exactly how these 2 categories look like, or how the data in each one of these categories look like. And you can see from the not empty category, we have something that looks like this. So basically we have cars. These are images from cars. And if I show you many different pictures, you can see that in all of them we can see pretty much the same situation. It's like a car. That's basically the not empty category. And then if I show you the empty category, this is pretty much an empty something. This is pretty much all images containing emptiness, containing a completely empty these are completely empty images. In some of them they are very small objects, but you can see that all of the images are mostly empty. And these are how these 2 categories look like. This is how these 2 categories look like. And this data comes from one of my previous videos where I show you how to create a parking slot detector and counter using Python and computer vision. In this other video, I show you how to take a video exactly like this, from a huge parking lot like this, and to make it look like this. Let me execute the code I show you how to build in this tutorial, and the idea was to go from here to here. The idea was to build something like this where we detect absolutely all the parking slots, and for each one of the parking slots we classify if the parking slot is empty or not, and if it's empty we plot it in green, and if it's not empty we plot it in red. So this is exactly where the data comes from, the data we are going to use in today's tutorial. You can see that for the not empty category, this is how the data looks like. These are images from parking slots containing cars, and from the empty category we have images from parking slots which are completely and absolutely empty. So this is the data we are going to use today. And the image classifier I'm going to show you how to build in today's tutorial, it's a very robust classifier in situations like this, in situations where the data we have, in situations where the classification we want to make on our data, it's very easy, it's very simple, right? Where the different categories we want to tell apart, the different categories we want to classify, they are visually super distinct. They are super different, right? In this case we have images from cars, and in the other category we have absolutely empty images, right? The image classifier I'm going to show you today, it's very robust and it works super well in situations like this. And the reason I'm saying this is because this may not be a state-of-the-art image classifier. If you look for papers or if you look for the most recent techniques, obviously you are not going to find the classifier we're going to make today, we're going to build today. And it's definitely not the most robust classifier in the machine learning industry. But if you want to solve like a very simple problem like the one we are going to solve today, this image classifier will be more than enough. And I'm going to show you exactly what's the performance we achieve with this classifier, but that's later on in this tutorial. Now, let's get started. I already showed you the data we are going to use, and the first thing I'm going to do is to import OS, which is a library which we definitely need in order to work with data and to read data and to load data from our computer. So I'm going to define a directory which is input directory, and in this case I'm just going to hard code where the input directory is located, which is here. This will be something like this, and then I'm going to define our categories, and I'm also going to hard code it, and I'm going to say something like this: our categories are empty and not empty. Okay, and then the only thing I'm going to do is to define two lists, which are the lists which are going to contain our data. One of them will be data, and then the other one will be labels. And I'm going to show you exactly how we're going to use these two objects later on this tutorial. And now what we're going to do is to iterate in absolutely all the images in these two directories, and we are going to load these images, we are going to read these images, and we are going to format the images, this data, in a way that fits well the classifier we're going to use later today. So let's start with it. I'm going to say something like for category in categories, and then for file in something like os list dir input dir, and then I'm going to define the image path like os path join, and then input directory and category, and sorry, this will be os.path.join input dir and category. Okay, because we are working in absolutely all the files for each one of our categories, right? Something like this. Okay, image path join input dir category, and then file, and then we have defined exactly what's the location of our images. Now the only thing we need to do is to read our images and to save our images into this list. So in order to read our images, I am going to import from skimage.io import imread. In this channel, in all the videos I have made so far, we usually used OpenCV as an image processing library, and obviously OpenCV is by far the most popular and the most comprehensive of all image processing libraries. It's the one I use the most in my projects. But there are also other libraries which are more convenient in different situations, and for example in this case we are going to use Scikit image. We're going to use this image processing library in order to read the images from our disk, from our computer. So I am going to call imread from image path, and this will be image. Okay, and now I'm going to resize this image, and for that I am going to import another function from Scikit image, which is called from Scikit image.transform import resize. So I'm going to call resize. I need to input my image, and I need to input the new size, which the new size I'm going to resize all my images to, which is 15 times 15, and this will be my image. So I'm walking through absolutely all the images in these two directories. I'm taking these images, I'm reading these images from my computer, and I'm resizing these images from this size to 15 times 15. Okay, now let's continue. I have resized all of our images, and what I need to do now is to append this data into the library, into the list I have created in order to contain all my data. So data.append, and we are not going to append the image like the image we have read and we have resized, but we are going to append the flooded image. We are going to take our image and we are going to make it into an array, right? Because currently our image is something like a matrix, right? It's something like a matrix of size, for example, in this case, 61 times 26 and 3 channels. It's BGR. We have resized this image. Now it's 15 times 15 and 3 channels. Now we want to take all of that information and we want to make it into only one very, very long array, right? We want to make it unidimensional. So that's why we are calling flooded. And the reason we are doing this is because that's what we need to do in order to use the image classifier we're going to use today. When we are working with machine learning, you will notice different classifiers and different models and different libraries and different different everything require different formats, or require we format the data differently in order to be fed into the machine learning model, into the classifier, or into the whatever we are using. And in this particular case, we need to flood the data. We need to make the data into an array before we input this data into our classifier. So that's all for the data, and we also need to append the category for this data, the label. And in order to do that, I'm going to walk through the categories in a slightly different way. I'm going to call this is category index, category in enumerate categories. And now I will append category index to this labels array, to this label list. And that's pretty much all we need to do. The only thing I'm going to do next is to cast each one of these lists into an NumPy array. So I'm going to say as array and then date. Okay, and I'm going to do the same with labels. NP as array labels. I know what you're thinking, hey Felipe, this is not going to work because you have not imported NumPy. And you are completely right. So I am going to import NumPy now. Import NumPy as NP. Okay, so that is it. That's all we need to do in order to load our data and in order to prepare our data to be fed into the classifier, or in order to move to the next step. That is it. We have completed the first step in our process. So congratulations. We are one step closer to reach our goal of training our image classifier. Now, in order to make sure everything works properly and we don't have any error, I'm going to execute the code as it is now. And NumPy has no flooded. Maybe it's flattened. I think it's flattened. Maybe I made a mistake. So let's see what happens now. It seems we don't have any error. So yeah, I made a mistake. Now we have to wait a few minutes because remember, we are working through absolutely all the images in these 2 directories. And we have, among the 2 directories, we have 6,090 images. So this is going to take some time, but yeah, now it's completed. And now it's time to move to the next step, where we are going to split our data into 2 different sets. We are going to create a training set, and we are also going to create a test set. The training set is the one we are going to use in order to train our image classifier, and then the test set is the one we are going to use to test the performance of the classifier we are going to train. So we definitely need to split all of our data into these 2 sets, and this is the function we are going to use. We need to import another function from Scikit learn, and this function will be something like from Scikit learn dot model selection, if I'm not mistaken, import train test split. Yeah. So this is how we are going to use this function. I'm just going to write some things and then I'm going to explain it. So this will be something like xtrain, xtest, ytrain, ytest. This calling our data x and y, it's a very popular convention in machine learning, so we are going to do it too. And this will be our train test split function. And we need to input data, labels, and then there will be other parameters as test size. I'm going to set this in 20 in 0.2. Don't worry, I'm going to explain exactly why I'm setting all these parameters in a couple of minutes. Then another parameter is stratify. This will be according to labels, and then shuffle. I'm going to call shuffle here. and this will be true. Okay, so I have called train test split. I have input our data and our labels, and then I have specified a few parameters. In order to show you exactly what these parameters mean, I'm going to start with test size. I told you we were splitting our data into two different sets, the training set and the test set. Now let me show you an image to show you more what this means, to show you exactly how this looks like. So this is an image I found online. This is an image I found on Google, or actually on DuckDuckGo. And basically you can see that we have an array which is called data, which contains all of our data, and we're creating two different arrays from it. We are creating xtrain and xtest, and we are specifying this size, this split size, which is 0.2. So what we are doing is creating two different sets, which are training set and test set. From the total amount of our samples, from all of our data, we are splitting all of our data into two different sets, and the way we decide what's the size of the test set is by specifying this parameter. So currently we are telling train test split to make this split in a way that 20% of all of our samples are in the test set, right? Now, moving to the next argument, shuffle equal true. This is something that we always want to do when we are creating data, when we are preparing data in order to be fed into a machine learning classifier. We definitely want to shuffle this data first, so we can avoid absolutely every bias we had when we were reading the data, when we were creating these data arrays. We definitely want to shuffle the data first. This is a very good practice. Sometimes there are some biases which we are not aware of. Sometimes the way we are reading the data or the way we are creating these arrays, we are making some mistakes, or we are, I don't know, the way this walking is done, maybe it's alphabetical order, or maybe it's whatever. We always want to shuffle the data first. That's a very good practice to avoid any type of bias when we were reading the data and creating these arrays. Then stratify equals labels. I will say it's always a good practice when we are splitting our data into two different sets to define exactly how we are stratifying this split. And in order to show you exactly what stratify means, I'm going to show you this picture, which I also found online on DuckDuckGo. And basically you can see that we have a data set. In this case is these 12 people, and you can see 3 of these people are blue, 3 of these people are green, and then 6 of these people are red. And in this example we are taking a sample of 4 elements of 4 people, and the way this sampling is done is by stratifying by the different labels. So if you look at the sample, you can see that 2 of these samples are red, 1 of the samples is green, and the other one is blue. So we are keeping the same proportion of the different labels in our original dataset. That's exactly what we are doing when we are stratifying according to the labels. It's like a way to make sure that all the different labels are going to be in exactly the same proportion as in the original dataset. So it's definitely a good practice. This is something we always want to do. Now let's continue, and you can see that we have completed the second step in our process. We are one step closer. We have only 2 steps left, 2 steps to go. We are one step closer of training our image classifier, and that's going to be all for splitting our data into a training set and a test set. Now it's time to train our image classifier. Now it's time to do like the actual training. And this is how we are going to do it. I'm going to import another function which is called, if I remember correctly, from sklearn. I think it's model selection as well. Import grid search CV, and then from sklearn.svm import svc. Okay, so the first thing I'm going to do is to define an object which is called classifier, and this will be something like this. This is the classifier we are going to use. It's svc. Let's see if it's okay. Sklearn svm export. I think it's okay. For some reason it doesn't really found it. Oh, I see what's the error. SVC should be in capital letters. And now everything should be okay. Okay. So what I'm doing here is creating a new instance of this object, and I'm calling this object classifier. And this is the classifier we are going to use in order to train our image classifier. So what I'm going to do next is to define another object, which is parameters. And this will be something like this. I'm just going to write it and I'm going to explain it in a couple of minutes. I'm going to define something like a list of only one element, which is going to be a dictionary with two keys. One of these keys will be gamma, and then the other key will be C, and that's pretty much all. And then I'm going to define a list for each one of these items. And for gamma, it will be something like 0.01, 0.001, and 0.0001. Okay. And for C, I'm going to do something like 110, 100, and 1000. Okay. And then it's when I'm going to call grid search. I'm going to define a new object, which is called grid search. And this will be grid search CB. And I'm going to input these two objects I just created, the classifier and the parameters. Okay. And now let me show you exactly what I'm doing. I'm creating a new instance of SVC, and I'm calling this instance classifier, and this is the classifier we are going to use. And I'm creating this object which is called parameters, which is a list containing only a dictionary, and this dictionary has only two keys. One of them is gamma and the other one is C, and each one of these keys has a list of values. Okay. Now I'm going to show you the scikit-learn documentation. I'm going back to scikit-learn, and I'm going to show you how the documentation looks like for SVC, for the object we are using as our classifier. And you may notice all the different parameters we have in this classifier. We have C, kernel, degree, gamma, coef0, shrinking, probability, and many other parameters. We have many different parameters to choose from. But when we were creating our object, we are just calling this empty constructor. We are not specifying absolutely any parameter. We are just using all the default values for SVC. Okay. And you may notice as well that we are creating this other object, and these two keys we are creating are exactly two parameters from our SVC, from our object, from the object we are going to use as our classifier. So what we are going to do is we're not going to train only one image classifier. We are going to train many different image classifiers, and we're going to train an image classifier for each combination we have for C and gamma. So we have 3 values for gamma and we have 4 values for C. This means we are going to train 12 image classifiers, right? The way this process is going to work is that we are not going to train only one image classifier, but we are going to train many, and as many as different combinations we have for C and gamma. In this case, we have 3 values for gamma, 4 values for C, 3 times 4 is 12, so we are going to train 12 image classifiers. That's the process we are going to take in this tutorial, and the way it works is that we are going to choose the best of all of these different classifiers we are going to train. So, and the way we are going to do this training, the way we are going to train as many classifiers as at once is by calling grid search, by calling this other object I have specified over here. So this is how we are going to use it. I have already defined this grid search, and then the only thing we need to do is to call grid search dot fit, and I'm going to input xtrain, which is my training set, and then whitetrain, which are the labels of our training set. And that's pretty much all. That's pretty much all in order to train our image classifier. That's pretty much all to train all these 12 image classifiers, right? Let's see what happens when I press play. Now, remember the way this works is that we are loading the data first, and this is going to take a few minutes because it's a lot of data. These are a lot of images, and then we are taking this process. Now the training also takes some time because remember we are training many different classifiers, so this is going to take some time. So I'm just going to wait a couple of minutes and I'm going to see if something happens or if the execution is successful. Okay, so the execution is now completed, we don't have any errors, so we can continue. And this was the third step in our 4 steps process. This means we are pretty much there. The only thing we need to do now is to test the performance of the model we trained. But we are almost there. We have almost completed this process, and most importantly, we have already trained our image classifier. Our image classifier is now trained. The only thing we need to do now is to test how it performs to see if we can use it or not. Okay, and this is how we are going to do. I mentioned that we were training not only one image classifier, but we are training 12 different image classifiers, one for each combination of C and gamma. So we are training many different classifiers. And the way we are going to select one of all of these image classifiers is by calling a member of grid search, which is called gridsearch.bestestimator_. So by calling this member is that we are going to get the best of all the different image classifiers that were trained, right? We are training 12 different image classifiers and we are just choosing the best one. And the way we are choosing for the best one is by calling this member of grid search. That's basically what we are doing. So this is our model, this is our classifier, best estimator, this is our model. Now let's see how it performs, let's see if it's really like a good classifier, let's see what's the performance of this classifier on our test data, on the data we have created in order to test the performance of this algorithm. So what I'm going to do is to call bestestimator.predict, and I'm going to input my test data. So I'm going to input xtest, and I'm going to call the output from this prediction yPrediction, right? And then I need to import another function, which is from sklearn.metrics import accuracy score. And let's see what's our performance. And I'm going to make a print. I'm going to define another value, which is score, and score will be accuracy score, yPrediction, and yTest, right? I'm taking these, which are the labels of the test set, and I'm just comparing against our predictions. And now I'm going to print something like, I'm going to format this super nicely so we get like a very clear measure of how well this performs. So I'm going to express this as a percentage, and I will say something like of samples were correctly classified, something like this. And this will be format string score times 100, right? Because score is going to give us a number which ranges between 0 and 1, and it's going to be a measure of our score, of how accurate our classifier is on the test set. Now, this is a value between 0 and 1, and it's very useful, and that contains absolutely all the information. But what I'm going to do is just reshaping, we're going to do like a reformat of this number into a percentage, right? Because it's going to be much cleaner in order to see how it performs. And all I have to do now is to execute this code again, and let's see what happens. Let's see what's our performance. So I'm just going to press play, and I am going to wait a couple of minutes just like before, and I will come back with our results. Let's see how it performs. The execution is now completed, and this is the accuracy we got with the best estimator from all the different image classifiers we trained. We are getting a 99.9% accuracy. This means that this is absolutely perfect. This is a pretty much perfect classifier. A 99.9% accuracy is like a super high performance. It's like a very good performance. So we can definitely use this classifier later on. We can definitely use this classifier in order to use it in our project. So the only thing we need to do next, the only thing we have to do now in order to complete this tutorial is to save this classifier, to save this model, because we want to load this model from another project, or we want to load this model in a different code or in a different whatever, from a different location. We definitely want to save the weights, or we want to save exactly all the information which is related to this model so we can use it later in a different project. And the way we are going to save this model is by using pickle, which is another Python library. So I'm going to import pickle, and then I'm just going to call pickle.dump, and I'm going to specify the model I want to save, the object I want to save, and also I need to specify the file, which is going to be something like model.p, and then I need to open this file as wb. Okay, and that's going to be pretty much all in order to save our model and in order to have a file with our model so we can use it later on our project or from our location, or we can use this file in whatever way we want. So I'm going to press play, and that's going to be pretty much all. After the training process is completed and after everything is done, we should have a file in exactly the location we have specified, which in my case is here, where we should have a file which is called model.p. So this is it. This is going to be all for this tutorial. We have absolutely completed all the steps in our process. We have completed all 4 steps in our process, and we have trained an image classifier using Python and Scikit-learn. So if you enjoyed this video, I invite you to click the like button, and I also invite you to write me a message in the comments section below telling me what do you think about this video, telling me what do you think about this tutorial, and also telling me your ideas or your recommendations for other videos or other projects we could work next on this channel. My name is Felipe, I'm a computer vision developer, and in this channel I make tutorials, coding tutorials exactly like this one, and I also share my experience and my resources, the resources I use as a computer vision developer. So if these are the type of videos you are into, I invite you to subscribe to my channel. This is going to be all for today, and see you on the next video.